Over the last few videos, we've been going over the build of this LED clock. Today's video, we'll go over the wiring and firing it up for the first time. So the next thing is lots and lots and lots of cabling. So I have to make around about 40 of these things. So these are the little connectors. One LED strip comes in, one LED strip goes out, and it goes round in a sort of like an S shape throughout the whole thing. So I've cut lots and lots and lots of cable. I've now got to make all of these. Well, that took a while, but we now have all of these parts ready to be soldered into the clock. We also have these other 4 special ones with a fly lead on them. Now this is to provide 5-volt power in various different places in the clock. So one of the lessons learnt in Mark II was that there is a resistance along the path of the LEDs that every so often will drop, meaning that the LEDs appear yellow rather than white. So what these do is these allow us to put 5 volts in at various different points along the clock, which actually prevents the problem from occurring. So the next thing is to fit these to the frame. All right, so here's an example. So this one will go just there. Then this cable will go through the hole there and be routed through the back to connect up to here. And there'll be a connector block here, or I'll solder the cables together. I haven't quite decided. That will then lead into the center section. So off camera, I finished wiring up all of the connectors around the edges of the LED strips, which took a while. But now we're ready to wire up the rest of it, to wire it from the strips to the controller. So here's some more of the cable routing. These 3 connectors here go to the first LED of the strip, and then they'll come through to the PCB in the middle. The power cables, these 2, and this one from this side, will get wired directly to the power connector on the back. So they'll have to be soldered in like so, and then that will get attached on the top when the PCB is in place and everything. So I also had to crimp the connectors for the power for the PCB. Crimping is never really fun, and these connectors are absolutely tiny. But I've got to do this for the power. Then there'll be one for the LED strip, one for the temperature sensor, and one for the LDR. The latter 2 will probably just do off camera because it's exactly the same process. Just crimp more cables, plug them in. So just before I put the lid back on, show you where we are with this milestone. So the power connectors are all connected into the power connector at the back. This little fly lead goes off to the PCB, and then we have the one connected to the RGB LED here. There is an extra ground that comes off here, but given that we've got a ground coming off in other places, didn't feel the need to fit it, but it's there if we need it. It's always a good idea to test as you go along, just to make sure that everything works at various different milestones while you're working on the project. So with everything wired up sufficiently to run a test program, let's see what happens. So inevitably we had one strip that didn't want to work at all, so it had to be unsoldered and a replacement is going to be put back in here. All looks good. So I've buttoned it up now, added the diffusers and the edges, and that's the physical assembly now completed. In terms of software, I've used the version 2 software from the old clock, but I've just made a port of it for this hardware, which does mean that every pixel is double thickness, with the intention that later down the line I'll write proper software for this and utilize all the pixels that this now provides. So final test, and we'll turn off the lights for this. That's it for this video. If you like this sort of content, please like the video below. Don't forget to subscribe to the channel, and you can support me through buying me a coffee, link in the description below. That's all for today. Thanks for watching.